All right, so next up we're going to talk about what's called the remainder theorem. Now, when we divided p of x by p of x that was x to the fourth plus 3x cubed plus 2 by d of x equals x minus 1, we got a remainder of 9, right? And so the question I have for you guys is, well, what is p of 1? What is the polynomial evaluated at 1? So p of 1, we're going to say, okay, well, that's 1 to the fourth plus 6 times 1 to the third plus 2, which is going to be 1 plus 6 plus 2, which is 9. Now, is that a coincidence? No, of course not, right? So what we have now is what's called the remainder theorem. If we have a polynomial f of x and it's divided by x minus c, some divisor, x minus c, then the remainder is the value of f of x evaluated at c. So why is that, right? Now, remember, when we divide, if we do f of x minus over d of x, right, which in this case is going to be x minus c, that gives us our quotient, right, q of x plus some remainder, right? And it's really the remainder over x minus c. So that means when we write f of x, we can write, oh, it's x minus c times q of x plus our remainder, right? So let's see here. Well, what happens? What happens when we evaluate f at that value of c? Well, we get c minus c times q of c, don't really care what that is, times r of c, right? Which, of course, c minus c, this is 0, right? And 0 times anything is 0, so f of c is going to be our remainder when our polynomial is divided by x minus c, period, end of story, okay? So this can save us a little bit of time when evaluating perhaps some functions, and really every semester I get somebody who's like, you know, takes the long way to evaluate maybe this really complicated polynomial and it wants to know, well, what's f of 13? And it just had you divide the polynomial by x minus 13 and find the remainder. Just take that remainder, it's the answer, it's f of 13, right? And they do the whole long problem over again. But this remainder theorem motivates, there's the word, what's called synthetic division. And you may remember this from high school, hopefully, right? If we have our polynomial f of x, and we know that it's equal to x minus c times q of x plus some remainder, of course, that means f of c is equal to r, right? The remainder. Okay, so that's motivating what's called synthetic division. We can only use synthetic division when we are dividing by a binomial, so it is rather limited, but it's good for what we need it for now. We do have some requirements, right? We have polynomials need to be in standard form. We're going to write down only the coefficients. This is really just shorthand for long division. And we need to don't forget zeros for any missing terms. That'll get you, right? If you're going to make a mistake with synthetic division, it's going to be that. Okay, so how do we do this? Okay, so we're going to look at this. We want to divide this polynomial. So write all of this. This is our p of x. Right? Yep. All of this is our p of x. This down here is our d of x. Right? And so remember, the divisor, we're dividing by x minus a number. So in this case, that number is 2. We're going to put that in a little box, and then we're going to put our coefficients. So we have 1, we have negative 7, so there's no missing terms on this one, right? Cube, squared, x to the first, x to the 0. So we're just writing down coefficients, 1, negative 7, 13, and 3. All right. So what do? We're going to bring down the first term. okay? And then we're going to multiply. 2 times 1 is 2, and we're going to add. So negative 7 plus 2 is minus 5. Then we're going to multiply again. 2 times minus 5 is minus 10. 13 minus 10 is 3. And 2 times 3 is 6. And we're going to add, we're going to get 9. So this last number is our remainder. And the other terms, we're going to count up. We've got our constant term, we've got our x term, and we've got our x squared term. So we have that this division problem is equal to x squared minus 5x plus 3 with a remainder of 9. So pretty easy there on the synthetic division. We've got a few other additional examples, and we'll put those in the next video.